Why doesn't the moon have an atmosphere? It's a simple question, but the answer reveals a fascinating story about gravity, space, and the harsh realities of our nearest celestial neighbor. The moon, despite its closeness to Earth, is a completely different world. It has no air to breathe, no wind to blow, and no protective blanket of gas to shield it from the cold, radiation, or meteor impacts. But why is that? What makes the moon so barren while Earth is teeming with life? To understand this mystery, we first need to know what an atmosphere does. On Earth, the atmosphere is crucial. It filters harmful solar radiation, regulates temperature, allows for weather patterns, and supports life as we know it. It even helps keep water in its liquid state. Interestingly, recent discoveries on the moon have confirmed the presence of water ice in permanently shadowed craters near the poles. And yet, there's still no atmosphere to speak of. What's going on? The answer begins with gravity. Gravity is the force that holds an atmosphere in place. Earth's strong gravitational pull keeps gas molecules trapped close to the surface, forming a thick, stable atmosphere. It's the reason air doesn't just drift off into space. But the moon has only 1/6 of Earth's gravity. It's much smaller and less massive, which means it simply doesn't have the strength to hold onto gases. Any molecules that do appear, whether from solar radiation or meteorite impacts, quickly escape into space. This brings us to the idea of escape velocity, the minimum speed a molecule needs to break free from a planet or moon's gravitational pull. On Earth, escape velocity is around 11.2 kilometers per second, making it hard for gas molecules to drift away. But on the moon, that speed is only 0.4 kilometers per second. Gases like hydrogen and helium can easily exceed this and drift off into space. Over time, any gas the moon might have had was lost. That's why the moon doesn't have a traditional atmosphere like Earth's. Instead, it has what's known as an exosphere, an incredibly thin and unstable layer of particles that are constantly being replenished by micrometeoroid impacts and then lost again. It's not enough to breathe, and it offers no protection. Even the water ice trapped in the moon's shadowed craters isn't completely safe. Over long periods of time, some of it could sublimate or be ejected into space through impact events and the slow, continuous effect of solar radiation. Another reason the moon can't keep an atmosphere is because of solar wind, a constant stream of high-energy charged particles from the sun. Earth is shielded by a powerful magnetic field that deflects much of this radiation. But the moon doesn't have such protection. Without a magnetic field, solar wind particles hit the moon's surface directly, blasting away atoms and molecules that could otherwise stay around. Over billions of years, this solar wind has helped strip away any hope of a stable atmosphere on the moon. The consequences of having no atmosphere are dramatic. Temperatures on the moon swing wildly, reaching over 250 degrees Celsius during the day and dropping to below -170 degrees Celsius at night. Without an atmosphere to trap heat or spread warmth, these temperature changes are instant and extreme. There's no wind, no weather, and no protection from space radiation. The sun's rays strike the surface unfiltered, and micrometeoroids crash into the ground without ever burning up. This environment is incredibly hostile, not just to humans, but also to equipment. Astronauts need specially designed suits and shelters just to survive. And then there's the lunar dust. Without wind or rain to erode it, moon dust is sharp and clingy. It sticks to everything, tearing into fabric, clogging machinery, and posing risks to electronics and human lungs alike. And yet, even in this harsh setting, there's potential. The discovery of frozen water in deep, dark craters is a breakthrough. Water can support life, be turned into breathable oxygen or even used to produce rocket fuel. That's why NASA's Artemis 3 mission is planning to land near the moon's south pole, an area believed to be rich in these ice deposits. Understanding how this ice formed, where it is, and how to safely extract it could be the key to long-term lunar exploration. In the end, the moon's lack of atmosphere isn't just an inconvenience, it's a window into planetary science. It shows us how important gravity, magnetic fields, and solar radiation are in shaping the world's environment. It also helps us appreciate the fragile balance that makes life on Earth possible. As we look ahead to building lunar bases and preparing for missions deeper into the solar system, the moon stands as both a warning and an opportunity, a place that challenges us, teaches us, and inspires us to keep reaching beyond.